let's take a look at another sine cosine function. This time we're going to graph y equals 2 sine of 4x minus pi over 4 plus 1. And in this case, we are going to have a vertical shift, and we are going to have a phase shift. So we're going to go through and we're going to just catalog all this information, list out what we need to know, and then produce the graph based on it. It will be a sine function shaped graph. So all we really need to know are where are all these key points and axes and things going to occur. So I'll run through it with this one. In this case, well, we start with our amplitude, and our amplitude is equal to 2. For the period of the function, we know that we take 2 pi and divide it by b, so our period in this case, 2 pi divided by 4, that's going to give us pi over 2 as one complete period. Now, the thing about this is that our key points are always 1/4 of the period apart. So if I'm looking for my key points in this function, I would take 1/4 times pi over 2, and that means that each of my key points will be pi over 8 apart from one another. Okay, so far we settled on amplitude, period, and key points. Now, there is a phase shift. I find my phase shift by setting my argument, in this case 4x minus pi over 4, equal to 0, and then solve for x. So if I do that, of course, 4x equals pi over 4 means I would multiply both sides by 1/4, and multiplying by 1/4 gives me a phase shift of x equals pi over 16. And since that's a positive number, that means that we've got a phase shift of pi over 16 to the right. So when I'm making out my table of values here that I'm going to sketch into my graph for this particular function, for my x values, it's going to start at positive pi over 16, and each of those key points will be pi over 8 apart. Okay, so what does that mean? Well, that means I'm going to have to start adding increments of pi over 8. Well, pi over 8 and pi over 16, that means I have to get a common denominator of 16, right? So what is pi over 8? Well, pi over 8 is the same thing as saying 2 pi over 16. So what I'm going to be doing here with each of these increments is I'm going to be adding 2 pi over 16 to my original starting point. Well, 1 pi over 16 plus 2 pi over 16 gives me 3 pi over 16. That's my first key point. Adding 2 pi over 16 gives me 5 pi over 16 as my next key point. Adding 2 pi over 16 again gives me 7 pi over 16 as my key point. And then adding 2 pi over 16 gives me 9 pi over 16. And I stop here for one cycle because I have 1, 2, 3, 4, 5 key points within my cycle. So I'm done. Those are the key points that I'm going to want to have on my x-axis. Now if I go over here, I'm going to mark off my increments right here. So I'll make this pi over 16 right here, which is where I'm going to start one cycle of this sine function. I'm going to go to my next key point here at 3 pi over 16. My next key point will be at 5 pi over 16. Notice I'm just labeling all of these points equally apart. 7 pi over 16. As another key point, of course, 9 pi over 16 terminates for one full cycle. And I can always check to see whether or not this fits my idea of the period, because the difference between the end at 9 pi over 16 minus the starting point at pi over 16 should give me pi over 2, which is equal to my period if I've done it right. Well, 9 pi over 16 minus pi over 16 is 8 pi over 16. And sure enough, that reduces to give me pi over 2, my period. So it looks like I've done that part correctly. Okay, let's get to our y values. Typically, with the y values, we would normally think in terms of what does a sine function do? And a sine function follows the pattern 0, 1, 0, -1, and 0. However, each of those y values are being multiplied by 2. So we're going to take each of these values and multiply them by 2, but then we're also going to add 1. So I'm going to take each of my y values, multiply them by 2, from my natural sine function, multiply by 2, and then add 1 to each of those numbers to get my key points. Plus 1. Let's see if I can make it a nice looking plus instead of an awful looking plus here. Plus 1. Plus 1. Plus 1. Plus 1. Okay, so what does that mean? Well, the y value is 0 times 2 plus 1 gives me 1. So my first key point is that y equals 1. 3 pi over 16, I get 1 times 2 plus 1. That's equal to 3. 0 times 2 plus 1, well, that's equal to 1 again. -1 times 2 is -2 plus 1. That gives me -1. And then 0 times 2 plus 1, that gives me 1 again. So my y values look like I have a center axis at 1, because that's my vertical shift. So I'm going to draw my center axis right here. I always just dash that in lightly. And my key points right here. Here's 2, here's 3, here's 0, here's -1. So that looks like the bottom and the top of my cycle. So at pi over 16, I'm going to get 1. 3 pi over 16, I said I was going to get 3. 5 pi over 16 back to 1. 7 pi over 16 to -1. 9 pi over 16, one cycle ends at 1. And when we graph our function in there, we get this sine function shape in between all of these points that we plotted right here. Okay, so that's a really quick way of getting all those values. Of course, the graph continues on into more cycles, but the other bit of information we might be asked to provide the domain and the range. Well, the domain, it's a sine function, is really easy. The domain is going to be the set of all real numbers, -infinity to +infinity. Right? For a sine and cosine function, that's always true. For the range is defined by the center axis at 1 plus or minus this amplitude value. And in this case, we can actually see our lowest value goes as low as -1. Our highest value will be +3. So our range would be -1 to +3. And that would be this graph of y equals 2 sine of 4x minus pi over 4 plus 1. More to come.